National parks are really a unique jewel. They play a major role in protecting biodiversity. And a park manager really needs to know the resources that he has, and in order to protect those resources adequately.
To gauge anything, we need to know where the starting line is, and that's what we're doing.
It's not good enough to say we think they're out there. We're just really trying to build a foundation for explaining what we have.
I think that it behooves us to monitor our natural resources so that we can better manage what surrounds us.
If we desire to preserve the biological diversity of this planet, then we should know what is here.
There's sort of a web of things that are connected, and it doesn't seem prudent to start disrupting it without knowing how that all works.
Alaska's national parks preserve and protect some of the world's most scenic and important natural resources for all to enjoy. But how can these resources be best managed to ensure their survival for future generations? A critical first step is a consistent, comprehensive resource inventory. Managers must know what's out there in order to monitor the health and condition of our national parks. To help meet this need, the Park Service initiated an inventory and monitoring program across the entire park system. In Alaska, many of the vast and remote park lands have had few, if any, systematic inventories of the plants and animals that inhabit the landscape. Alan Bennett works with the Inventory and Monitoring Program in Southwest Alaska.
It starts with knowing what you have, knowing what resources are out there, whether they're unique geologic resources, whether they're threatened and endangered biological resources. That's kind of the first step, and in order to protect those resources adequately, you really have to have some very credible knowledge of where they are.
Bennett is the coordinator for the Southwest Alaska Network, which includes Katmai National Park and Preserve and Alagnak Wild River, Lake Clark National Park and Preserve, Kenai Fjords National Park, and Aniakchak National Monument and Preserve.
There had been almost no broad-based inventories like this that had been attempted in these parks. So the inventories were envisioned as roughly a 4-year effort, an effort that would be driven by the interests of the parks. The parks got together and decided what they thought were their highest priorities, which were biological resources, either plants, fish, birds, or mammals that they thought they knew least about and needed to know more of to adequately protect.
In the end, park managers decided to focus on 3 main areas for the inventories: small mammals, freshwater fish, and vascular plants. They also completed inventories on resources such as intertidal invertebrates and land birds as time and budgets allowed.
And the overriding theme is science-based management to generate information, knowledge of these park resources that will better allow us to protect them and to interpret those resources for the public. We put our investigators and park staff together around the table, took a look at the maps, and decided where potentially we could get logistically that might reveal the most discoveries concerning plants and animals in these parks. We had the primary objective of trying to document 90% of the species that were expected to occur in these parks. And by expected, I mean the overall distribution maps indicated that because this park fell within the overall broad line of this species occurrence, that it probably occurred there, even though it had actually never been verified. Secondary to that was getting information on species that could be rare or possibly threatened, and knowing if in fact they occurred in a park. Clearly, if you have a species like an exotic plant, knowledge of that early on is very important. A manager would be able to control that species before it really does serious damage in its park. And then ultimately, connecting that information, which is a really important part of this program, connecting it both to the park manager and park visitors that ultimately influence the ability of the Park Service to protect these places.
A remote bay on Aniakchak Lake in Katmai National Park was just one location of many where small mammal species were inventoried. Researchers and graduate students affiliated with both the University of Alaska and the University of New Mexico conducted the work. Steve McDonald is a research associate who brings years of experience collecting and identifying small mammals.
We look at the landscape right here. We have a meadow and the old cabin and mixed forest around. And until you've done this a while, you cannot appreciate how alive the world really is. There, in boom years, there could be several thousand animals in my range of view, but they're unseen and unknown.
McDonald and his team wasted no time preparing the tools of their trade to sample this unseen part of wild Alaska. They hope to locate and identify up to 20 different species of small mammals.
That includes for us the shrews, the small rodents, some of the larger rodents, traditionally the non-game species that aren't usually studied, like marmots, snowshoe hares, bats, muskrats, and so forth. This diversity of animals, we use a diversity of techniques from snap traps to pitfall traps to live traps. The standard method is we use these 44-ounce cups as pitfalls and bury them in kind of flush, the top is flush with the ground, and that's primarily for shrews. We also have these museum special snap traps, baited, that capture a number of the other small rodents. Right now, this is our first full day here. We must have about 600 traps out, and that's pretty standard, sometimes up to 1,000 traps. It sounds like a lot of traps. Right now we're experiencing, this year it seems a very low number of animals, so it takes a lot of effort to get the animals. Nothing. Nothing. Not a thing. Nope.
Eventually, though, their efforts began to produce results. Specimens were carefully collected for later analysis.
Every animal goes into its own little bag so that we don't mix up ectoparasites between animals. I also have a shrew in the pitfall, pretty wet. Probably monticulus, but as with a lot of these numbers of these small mammals, you can only tell in the hand, and I have to use a magnifier to look at the tooth pattern to be able to for sure confirm what species it is. They're very similar. Again, that's one of the reasons why we collect. A sighting of a little running shrew is not going to help you any. To have valid records, we need vouchers, something that can be checked 50 years down the road, and to validate its legitimacy of a record. Also, we need series of animals for these various studies that various students are doing or people will be doing in the future. And also, a lot of these animals, shrews and small rodents in particular, are extremely difficult to tell apart. You need to look at them in the hand. The shrews in particular, you need to look at the teeth to be able to identify these things. So we do collect series. And these have extreme value, especially as time goes on. And various changes on this planet, you have a series of animals from a particular place, a particular time. We're also collecting tissues for DNA analysis, some ongoing studies and for future studies. We're also collecting parasites, both endoparasites and ectoparasites from these animals, and maximize the use of these specimens. A primary goal for the Park Service is to get a complete list of all the small mammals that occur in their park. And so what we're calling small mammals, there's a potential of 20 species that we could document in the park. I think we're up to probably about 9 species. That's 20 species, that's close to about a half of the land mammals of the park. And again, they're an important but hidden element of the fauna. A fundamental value, I think, and an importance of our parks is to preserve the biological diversity of the area. What we're doing is inventorying to actually describe and voucher that diversity. If biological diversity is a value of high importance for the society, then it's important that we know what that diversity is, and thus the inventory.
Freshwater fish were also identified by park managers as a resource they needed to know more about.
I guess I would liken it to turning over stones and just seeing what comes out, what comes crawling out from underneath. You never know. And so we'll go to these lakes and we'll try to find what fish species are present. It's really a lot of fun. It's a constant feeling that you're exploring, even though it's not, we're not climbing mountains, we're not trekking across a desert. We're just going to these little ponds, but there's so much going on there. It's fascinating. Any net that you can imagine, we try. Traps as well, small minnow traps and larger traps. They're all pretty effective for catching fish, and that's really the idea. When we go out there, we're trying to catch these fish just to document what species are present. And if we can get other biological information like size or length or weight, any different variable that would explain some part of their life history or some part of the variation that's present there, we'll try to collect that as well. So it's a pretty straightforward thing when it gets right down to it. It's fishing, and we enjoy it. Again, we're targeting all the fish that are present. So hook and line is appropriate for some species like trout and some of the larger salmonids, but to catch a sculpin or a stickleback, you have to use a little bit different stuff. And so we'd use a minnow trap or maybe a seine for those smaller species.
Researchers baited fish traps with a mixture of salmon eggs and fish oil. With bait suspended inside, each trap was placed in a sampling location and left for an hour or two. GPS coordinates for each sampling location were recorded, along with water quality data, such as water temperature, conductivity, percentage of dissolved oxygen, and pH level. These data will help park managers detect changes over time when sites are selected for long-term monitoring.
I think we've done a good job at sort of meeting the goals of the inventory, which is to document 90% of the expected but previously undocumented species. But what you can do is take a biogeographical look at an area and take the existing literature that's out there and form sort of a picture of what should be there. So based on what we know about the area and based on the distributions of fishes throughout the region, we feel pretty good that the ones that we've found belong in these areas, that we've captured most of the representative species. We're just trying to build a foundation for what's out there. So we'll be analyzing the length frequencies, and we'll try to look at how species composition changes across parks and just some of the basic stuff. But we're just really trying to build a foundation for explaining what we have so that we can later apply it to the management.
Teams of botanists, including National Park Service employees and experts from the University of Alaska's Natural Heritage Program, were flown into remote locations such as the volcanic caldera of Aniakchak National Monument to complete the vascular plant inventory. Amy Miller, a National Park Service ecologist, was part of the team in Aniakchak.
There were 4 of us in Aniakchak. In the other inventories, I think there were a comparable number of field people. I think what was really interesting up there were these really dramatic moonscapes. There are areas where there are old lava flows and really blocky, kind of jumbled rock and some scree and talus slopes on the inside of the caldera where we found, I know we found at least one species there that hadn't been reported before from the caldera. Mainly what we collected there were very inconspicuous species that you'd normally just step on. You wouldn't even notice them, and I think that's why they hadn't been reported before.
Miller and the team spent 4 days camped inside the caldera, covering scores of miles on foot to document the plant life.
And so you spread out and you walk a grid or a semi-grid. I mean, you walk in parallel and you're all kind of looking at your own swath of ground. And what we're covering are kind of contiguous areas of what looks like the same sort of community. So I wouldn't wander from a meadow into a boulder field. I would probably finish the meadow area, try to document everything that I found there, and then move into the boulder field. And once we found species that had not been reported from the parks before, they might have been expected, or maybe they weren't expected at all, then we collected those. And the collections, they include both the above ground part of the plant, the part that we see, and they have to include flowers and fruits so that we can identify them. But we also include the root system because often that can be diagnostic for the species. So we dig up these plants, we collect them that evening, we press them in a plant press, and this is a way that we can preserve them. And then they're later identified if we can't identify them in the field, and they're sent up to the University of Alaska Fairbanks for determination. And they're archived up at UAF as well, so that anyone can go into the herbarium and look at what was collected in Aniakchak or Kenai Fjords.
This kind of documentation forms a cornerstone of the long-term monitoring efforts.
One thing I've realized since I've been working on these inventories is how important it is to document what you see, and in this case document it with collections, because I can go out in the field and say, oh yes, I saw this plant, but unless you have a specimen to go along with that observation, people coming along 10 years from now won't necessarily know whether they can believe you or not. So I think these collections will form a very important archive. 100 years from now, we can look at what we find and say, has it changed? Have the species changed in abundance, and have they changed in terms of where they are in the landscape?
The biological inventories are just a first step, forming the baseline from which long-term monitoring can begin.
We're overall real pleased with the inventories, recognizing that they were kind of a first round effort. Ultimately now, reflecting on what we learned during that exercise, there's some logical places to visit next. And opportunistically, as opportunities and funding becomes available, I think with each of the inventories, we have a good idea where we would go and what we would look for if we were able to go back and have a second round on each of these.
The results of the inventories have provided Park Service managers with a greatly expanded knowledge of the resources they are entrusted with, as well as contributing to basic scientific knowledge about the abundance and distribution of plants and animals.
In Kenai Fjords, the plant list before we initiated the vascular plant inventory numbered some 240 species for the park. After the inventory, we were able to add another 212 species that were previously undocumented in that park. So in this particular case, we nearly doubled the known occurrences of vascular plants.
The next step is to develop long-term monitoring methods and protocols that will help detect changes in the park ecosystems.
The monitoring program, unlike the biological inventories, is kind of an integrated program, in that we're not just looking at plants and animals, but we're also looking at physical resources, in the case of water quality, water chemistry. So unlike the inventories, the long-term monitoring effort is an ecosystem approach.
The monitoring program will combine large-scale observations from sources like satellite images and aerial photography with finer-scale observations from on-the-ground visits to characteristic plots or sites of known sensitivity.
So it's a far broader-based program, has slightly different objectives, whereas an inventory is kind of a point-in-time look at what are your resources at this particular moment. The long-term monitoring effort is looking at trends in those resources over time and over space.
Keeping an eye on these vital signs will help us gauge the health and guide the management of the national parks in Alaska.
Well, national parks are really a unique jewel. I've heard them, described as kind of the inspiration for Americans. In that, they're these places where we can go and see remnants of these last functioning ecosystems, where the drama of nature is still largely playing out, unaffected by humans. The country's blessed in having a national park system